In this section, we're going to dig into the CPU and see how it works. Also, we'll see the architecture of a simple CPU. We'll understand the core and thread concepts. So what is a CPU? As you know, CPU stands for Central Processing Unit, and you might know it as the brain of the computer. Every process in the computer has been done by the CPU. If you're trying to add two numbers, or if you want to show the hello on the monitor, CPU does the calculation. But how? Let's see. For now, let's assume that the data has been stored on RAM somewhere on our computer, which you can see on the right side of the screen. And also you can see a very simple architecture of CPU at the left of your screen. When we're talking about data, we mean any data, like addresses and instructions. As you know, the basic definition for application is a set of instructions. And these instructions are stored in the memory, like load, add, store, compare, and etc. As you can see on the screen, CPU has wires, registers, and some other components like ALU, Arithmetic Logic Unit, Control Unit, and Cache. The Control Unit fetches internal program instructions from the main memory to the processor instruction register, and it generates a control signal based on the contents of this register to supervise the execution of these instructions. It's the center of operations. It receives and decodes instructions and then sends out commands to the other components. Registers are very tiny memories that are very fast. The size of the register, sometimes called the word size, indicates the amount of data with which the computer can work at any given time. The size of a register may be 8, 16, 32, or 64 bits. Modern computers have 32-bit or 64-bit registers and are referred to as 32-bit and 64-bit processors. A 64-bit processor can process the data twice as much as a 32-bit processor. In 32-bit CPU, each register is 32 bits wide and can manipulate 32 bits of data at a time. Some important registers are Memory Address Register, or MAR, that holds the address of the current instruction that is to be fetched from memory, or the address in memory to which it is to be transferred. In other words, it specifies the address in the memory for a read or write operation. So we have one register that keeps the address of something. Another register is Memory Data Register, or MDR, that holds the content found at the address held in the MAR. And one more register is Program Counter, or PC, that holds the address of the next instruction to be fetched. Current Instruction Register holds a machine instruction that is currently being executed. So PC points to the next instruction that we are going to execute, and CIR points to the current instruction that we are executing. ALU, or Arithmetic Logic Unit, is part of a CPU that carries out arithmetic and logic operations on the operands in computer instruction words. The inputs to an ALU are the data to be operated on, called operands, and a code indicating the operations to be performed. The ALU's output is the result of the performed operations. CPU does 3 tasks: fetch, decode, execute. Well, let's see what's happening in these 3 steps. So getting a start, let's have some agreements. On the right side of your screen, you can see a couple of data. Let's consider it as a RAM that contains some data. And in the left side of your screen, you can see a CPU, which, as I mentioned, it has some components like registers, PC register that holds the next instruction, MAR that holds an address, MDR that holds the data, and CIR, which holds the current instruction. Also, there is a control unit and arithmetic logic unit and accumulator. Accumulator is another type of register, which I'll explain it later. Let's see what's happening in the first stage. But before going to the first stage, one more thing that we need to know about is some wires that they are transferring data, addresses, and some control signals. For example, CPU needs the data of the one memory location of RAM. CPU sends the address through the address bus, and by turning the enable wire on, tells to the RAM that, hey, I don't need to store anything. I need the data of this location. And RAM sends back the data of that location through the data bus to the CPU. So let's see what's happening in the fetch stage. That's the first stage. CPU gets the instructions from memory to do them one by one. When you turn the computer on, the PC register points to address 0. PC sends this value to MAR through the address bus. As I mentioned, MAR holds the address of the next value or instruction to be fetched or stored. When it's stored on the MAR sends it to the memory through the address bus, and RAM sends back the value of this address via the data bus to the CPU. The returned data is a value and it's not an address. So it will be stored in the MDR, which holds values and instructions to be used by the CPU. If the value is an instruction, which it is in our case, it's automatically copied from the MDR to the CIR, which is current instruction register. The instruction is finally copied to the control unit. But before it completes the fetch stage, the control unit sends out command to increment the address in the program counter. Now let's see what's happening in the next stage, which is decode stage. The control unit decodes the instructions like load 3, which means the instruction is load and the data that should be loaded is stored on the address 3 of the memory. The value of address 3 of the memory will be sent to the accumulator. The accumulator is a special purpose register, which is like a warehouse where data is temporarily stored while mathematical and logical operations are performed by the ALU. The ALU uses the data stored in the accumulator to process calculations. Now the control unit has the instruction, which means the decode stage is complete and now can tell the other components to execute the program instruction. And let's see what's happening in the last stage, which is execute stage. The 3 in the load 3 instruction that we fetched and the control unit decoded is an address. So it will be copied to MAR and MAR will be updated. Then a signal is sent to retrieve the data stored at memory location 3. The value of memory location 3 is sent back to the CPU and is stored in the MDR because it's data, not an address. Finally, the value is sent to the accumulator. That was the cycle that loaded a number from the memory location 3, which in our example, that was number 13. The next cycle will be done in the same way, and the PC now shows 1, which is a sub-4 instruction. And that means the instruction is subtraction, and the memory location that contains the input is 4. And in our example, it is number 8. The sub-4 is being copied to the MDR, and the next instruction, which is located at memory address 1, is loaded. As I mentioned, sub is the operation, and 4 is the location of the data should be operated. The value of location 4 will be fetched by the CPU and will be sent to the ALU. Now the subtraction can be done. The number 13 that was stored in the accumulator will be sent to the ALU and subtraction will be done. And the result will be sent back to the accumulator to be used in another calculation or to be stored on the RAM.